I wait a few minutes so that everyone can join here. Okay, now still some of you haven't joined. Yeah. Okay, so let us start. Determine all primitive functions of the following functions. So we learned what the notion of primitive function is. So when we say that capital F is a primitive function for little f, it means that if you take the derivative of that capital F, it gives you the function, the little f. And we just learned about two formulas. Mainly they were based on guesswork, educated guesswork. And I hope that you agree with me, it was more than that, because we were able to find a primitive function for those functions which were not trivial to guess. Today I want to continue a little bit more exercises. This is an extremely important lesson, so we will continue this lesson in Math 4. And if you go to technical university, that would be a very main subject that you need to master quite well. Okay. Okay, so we had two formulas. If I have a constant function, what is a primitive function for that? K times x. Why? Because if I differentiate kx, it gives me k. And if I have x to some power, the primitive function is x to the power plus 1 divided by that number, a plus 1. Of course, this formula for trivial reasons works only when a is not equal to minus 1, because otherwise the denominator would be 0. These are particular formulas for particular functions, but we have two generic rules. This tells you that if you're interested to find the primitive function of the sum of two functions, you can find the primitive function for the first one, primitive function for the second one, and then add them. If you want to subtraction, if you want the primitive of the difference, you subtract them. And if you have a constant multiplied by your function, if you want to find a primitive function for this new combination, what you need to do, you need to focus on primitive function of the function, and then what you get, you multiply it by c. These are quite generic rules, and These are the only rules. This is not correct that the primitive function for f times g is equal to primitive function of f multiplied by primitive function of g, okay? Or this, these are not, these are the only rules. So these are generic rules, and this is our table. We have only 2 formulas in our table. We will add 2 more in Math 3C level. We add more in Math 4, and then you can add more when you go to university, okay? But this is a very important topic, so let us do some exercises. So, and then do you remember I mentioned also, so that these articles, you need to pay attention. Sometimes they ask you find all primitive functions. It means that it is necessary for you to respect that word and put this constant c at the end. It means that whatever I choose for constant c, still that's a primitive function. So the set of all primitive functions of the function is this plus a constant. If they ask for a primitive function, it means that you can choose c whatever you like, but of course the easiest and more comfortable one is choosing c equal to 0. And if they talk about the primitive function, I haven't talked about that yet, but hopefully we will cover that part here as well. Okay, but let me just do some practice, do some exercises for you so that you can see what type of problems we can face, okay? So let me start again writing some functions here for you. So number 1, let me write this with blue and the answer in black so that it will be more visible through YouTube. Okay. For example, we want to calculate a primitive function for this function. F of x equals to, very, very simple examples. I did it in the previous session. So I want to give you a little bit harder problems today, a little bit, okay? So this one to power 2. We want to find all primitive functions of this function. Okay, and then you can communicate with me if you are willing to. So I want to find all primitive functions for this function. Okay, do you have any suggestions for warm-up? You can communicate through Zoom with me. Sorry, may you please repeat?
You expand.
Yes, expand, thank you. So the first thing is expand. Why we have to expand? Because this function in its form that I have here is not in my table. You see, in my table, I only know about constant functions and the functions of this form, x to some power, and then these generic rules. So this is not exactly of that type. So it is not possible to start the process of finding the primitive function immediately. We have to change the form of a function so that it consists of the parts that can be used, the primitive function of those parts can be found using those formulas on the table. So this is why I have to expand first. The first 1 to the 2 is x to the 4, and then 2 times the first one times the second one is what? 10x squared, and then 25. Yes? So this is f of x. Now everything is ready because x to the 4 is exactly the second formula in the table. This is a combination of a number multiplied by a function. So I have to combine this rule with that table, that formula in the table. And this is a constant. And this is actually this formula in the table. And I am also using this generic rule. So you see, for this simple problem, all of the content in that box is used. The first row is used for the last part. The second row is used for this one and that one. The generic rule for addition is used because this function is combined of 3 functions, addition of 3 functions. And then this one, 10 times x squared. So I want you to have a good understanding. You can do it. I want you to do it very quickly, but I want you to respect that if one of those rules was not there, so it means that you are not able to calculate this. So this you need to appreciate. Okay, now what I do, I write the capital F of x. So x to the 4, according to the second formula in the table, it becomes x to 1 unit more. So let me write it as this one, x to the 5 divided by 5. Then here I have 10, so I would write it 10, and then x to the 3 divided by 3. And for 25, it's 25x according to the first rule. And because it is mentioned all primitive functions, you have to respect that by showing that you are writing a constant at the end. And of course, yeah, this is of course correct, but I myself prefer to write 10 over 3 multiplied by x to the 3, but that's completely okay. So let us not spend some time on it. Okay. We go to the next example. And if you have questions, please interrupt me, okay? There would be a few seconds delay, but no problem. Okay, so let me, for example, try to solve this problem. F of x is equal to x times x plus 1 times x plus 2. I want to find a primitive function for this one. So I have seen this common mistake sometimes from student side that they calculate a primitive function for x, which is simple, x is squared divided by 2, a primitive function for this and a primitive function for that. But be careful, this is not possible because that's a product of 3 functions. Even if you succeed to find the primitive functions for all these parts, you see there is no formula here that the primitive function of f times g is equal to the primitive function of the first one multiplied by the primitive of the second one, okay? So here, again, the story is the same. Okay, so let me change this color to blue to write the answers in black. Okay, so you want to find that. So f of x is equal to x times x plus 1 times x plus b. Oh, sorry, x plus 2. Okay, so for this reason that we are not allowed to find a primitive function for this, again, there is the same story. I have to be patient and change the form of the function. So by multiplication. For example, I can multiply this x in, it becomes x squared plus x, and then I multiply it by x plus 2. Still, it is not enough. I have to still expand it. So x squared times x is x cubed, and then I have 2x squared, then I have x squared, then I have 2x. And then I simplify it a little bit because there are similar terms involved, so it becomes 3x to the 2, and then plus 2x. Now everything is ready. I can find a primitive function. So you see that this is a little f, so the process of finding the primitive function hasn't started yet. I have just reformed the function in a form that I can use the table. Now I can write the capital F of x is equal to a primitive function for x3. Immediately in your mind, it becomes x to the 1 over 4, x to the 4. Yes? And this one, you can do it in your head as well. X to the 2 becomes x to the 3 divided by 3. But that 3 in the denominator will be canceled by this multiplicative constant 3 here. Yes? So you can just do it in your head. And then it becomes x to the 3. And the other one here, the same story. You see x is power 1. So it becomes x squared divided by 2. And then that 2 in the denominator will vanish with this 2 as a multiplicative constant. So I will get just x squared, and then I have c. And again, I hope you agree with me, it was not that easy, even though this function is not a complicated function at all, but it was not that easy to guess that function to be a primitive function to this. So if you want to check your answer, you need to differentiate that function and show that that function is equal to that one. Of course, if you differentiate it directly, you will not get the function in this form. You will get the function in this form, but it is the proof that this is equal to this. You can factorize that anyway. Okay, please, if you have questions, interrupt me. Okay, now let me give you another example. And I want to wait a little bit for you so that you can solve it yourself, okay? even though this is a live stream, but I cannot have a pause. So in the future, people should also take their pen and start solving the problem. Okay, so I will give you a little bit of time so that you can solve the problem yourself first. F of x is equal to 1 plus square root of x multiplied by 1 plus x minus the square root of x. So it's not easy at all to guess a primitive function for this one, but hopefully by calculation, you will give me the answer. As soon as you are finished, I wish you finalize it, simplify the answer, I don't know, and write it in the most beautiful way. Of course, beauty is a little bit subjective, but hopefully you know my taste, okay? So you can influence me, impress me by writing it in that form. Well, I'm waiting for you, okay? The final, simplest possible answer. I don't know, the number of people in Zoom is more than the number here. Yeah, so some people probably are cheating, yes, aren't they?
how should we submit the answer?
Just talk to me. Yes, you can read it if you're finished.
I think the answer is 2/5 times x to the power of 5/2 plus x plus c.
Yes, that's correct. Thank you. But you can make it a little bit more beautiful. Beautiful means that using search signs, this square root, this radical sign.
Oh, I think I know what you mean. You take x to the power of 5, but you take the root of that, square root of that.
Yes, and then some part of it can be flipped out from the square root sign. Yes. Okay, so you can continue with these examples if you're finished, but the people who have some problems here, please listen to me. I want to describe it again for you. So here, you see that I want to find the primitive functions for this function, but this is not the form that I have it in my table. So the first step is not starting primitive function, determining the primitive function process. I have to change the form. So there is only one way apparently, and that's multiplication, yes? So number 3, so I will start expanding this function. I multiply just polynomial, 1 times this, 1 times that, 1 times that, and then I will start multiplying the square root x inside. So it becomes 1 plus x minus square root of x. And then I start multiplying the square root of x there. So square root of x times 1, square root of x times x. So let me write it in this form. And a square root of x times the square root of x is just x. There is a negative sign, it is x. And you see that most part of it is actually simplified. So this part and that part are gone. One of them is positive, the other one is negative. And then again, the same story for x and minus x. So what is left for me is just 2 terms, yes? One of them is x, so one of them is 1, the other one is x square root of x. But from your previous experience, you know that this is also not suitable form. I have to write it as x dot, instead of square root of x, I write x to the half. And of course, I have to simplify this. So one more step, it's 1 plus, I have 2 exponents, I have 2 powers with the same bases and different exponents. So I would write this and I will add this 1 to 1/2, so it becomes 3 halves, yes? So you see, this was a little bit complicated, so this is a simple function, so I can immediately start the finding primitive function process. So the capital F of x is equal. A primitive function for 1, I have to use the first row, so it is 1 times x, which is just x. And then the next one, let me be patient, do it patiently, but I really expect you to be able to do these things in your head immediately. So this becomes 3/2 plus 1, and then I have x to the power of 3/2 plus 1. And then because we are supposed to find all primitive functions, you have to put this constant c at the end. But you shouldn't leave it like that. So 3/2 plus 1, if you do it in your head, by the way, you can do it a little bit simpler. So let me just write x. I want to get rid of this denominator 2 here. So I rescale this fraction. I rescale this fraction by 2. When I multiply the numerator by 2, it becomes 2. When I multiply the denominator by 2, I have to multiply both of them. When I multiply this by 2, it becomes 3. When I multiply this by 2, it becomes 2. So 3 plus 2 is simply 5. When you get 2/5 here, this is exactly the same number, but it is the reciprocal of this number. So it is definitely 5/2, yes? So I don't need to make it so big. So it becomes x to the power of 5/2. Of course, this is the end of the problem. If you want to, you can stop here. But let me change my color to show that this is not mandatory. If you stop here, you get the full points. But here, x to the power of 5 over 2, do you remember? This is the formula. It's extremely important to know these formulas by heart in this, at least this part. So square root of a is a to power 1 over 2. And if I have the nth root of a to power m, it is a to power m over n. Yes? So now, because usually we have worked, I don't know what about you, but I have all my life worked with the square root signs and things like that. This is, by the way, it's called the surd sign, S-U-R-D. And then it means that it's, for us, it's easier to write it in the form of a surd sign. So how should I do that? I use this. And technically, I have to write a 2 here because 2, you see, this denominator appears here, this numerator appears here, so it means that x to the 5 should appear here. But if it is 2, by convention, we don't write it there. So whenever you don't see anything there, it means that this is 2. But you can even simplify it more, yes? You can write it as x to the power of 2 to the power of 2 times x, yes? X to the 2 to the 2 is x to the 4. X to the 4 times x is x to the 5. But this power of 2 and this square root sign will cancel each other. So what is left for me is x squared multiplied by square root of x. This, for my eyes, is more beautiful. As I told you, of course, beauty is more subjective. But this is more practical in the future. If I want to calculate the value of this capital F, say at 4, most of you are more comfortable with putting 4 here than putting 4 there. Of course, the answers are definitely the same. So I would write it as x plus 2 over 5, x squared, square root of x plus c. This is the point. If I have enough time, I will stop here. Of course, I told you that this is completely correct. You can stop there. Okay, of course, the next problem is easy. The reason that I brought this up again, because of these 3 letters. Of course, you see that A and B are not variables. How should I know that? Because I have expressed f as a function of x. Okay, so when I express f as a function of x, it means that x is the only variable in the problem. If there are other letters involved in the problem, you should consider them as parameters. So you should consider them as constant letters there. So you need to treat them as constants, not as variables. So this is based on my experience. Sometimes you're confused. This is much simple. This is a very simple example, but the reason I brought it up is because I want you to learn about that. Okay, so here, if you don't mind, let me start solving that one. And still, if you think that this is so simple, you can continue and solve this one yourself. So number 4. If I want to solve this problem, what should I do? I multiply. I have to expand. So this becomes x times x, x squared. X times b, I would prefer to write bx. A times x is just ax. And then a times b is ab. Okay, so make sure that you understand what is going on. If not, please let me know. Now, this is the point that I can start immediately the differentiation, and I want you to fully understand what's going on. So here, x squared is just simple normal. It becomes x to the 3 divided by 3. So let me write 1/3 of x to the 3. Okay, but can you tell me what happens for the next one? Hello? No clue? Bx. What is a primitive function of bx? How should I solve it? Which one of the formulas in the table, if any?
Times x squared divided by 2.
Exactly, because b, I just told you, it's a parameter. It's not a variable, because when you write f of x, you are implicitly telling me that x is my variable. if there are other letters involved in the expression of that function, all those letters should be considered constant. Okay, so it is a constant. It's a multiplicative constant. It's exactly like, for example, I don't have it on the board right now. It's just it's like this factor of 2/5 or whatever. This is a constant. So what I do, I just ignore the constant. I am using this last rule. Multiplicative constant should be written there, and I concentrate to find the primitive function for x, which is x squared divided by 2. So I would write x squared here, and if you don't mind, let me put the division by 2 below b. It's better. And the same story happens here. So this becomes a over 2 x squared. But for the last time, what is the primitive function for ab? What is that? Okay, so it might be there are some delays, I cannot hear you, but because this is also simple. What is the primitive function of AB? AB is a constant. If I have any constant, if I ask you what is the primitive function for the constant, you say that constant multiplied by x, and if you're interested in all of them, plus its constant c at the end. So hopefully everyone understands that this is just ABX plus a capital constant c at the end. So make sure that you understand what's going on. If not, please interrupt me by asking questions. Even if I am solving another problem, you don't mind, because I know the delay, there is a little bit delay, so don't hesitate to ask questions. You are not interrupting at all, okay? So here we want to solve this problem. I don't know how many of you did solve this problem. If you have already done, you can just read the answer for me. Might be I can compare it with the solution in the book. No one? Okay, so if you haven't finalized the problem yet, just tell me, what should I do? What is the steps that will guide me toward the answer?
First, you expand the denominator, and then the denominator you take x to the power 2/3.
So these are two steps, and one more step. Can you just talk about that one as well?
Then you simplify it with you take the powers.
Okay, so okay. Just let us do what you said. That's completely right. So what Dylan is saying is actually we multiply expand the numerator, so it becomes x to the 4, and then x2 times minus 2 is minus 2x squared, and then 1 times x squared, and then I have 1 times minus 2, and then hopefully every one of you now have this experience that surds are not useful in integration, yes? Yeah, so we have to rewrite it in the exponent form, and I just wrote the formula here. I raised that. This 2 goes for the numerator in the power, and this 3 will go to the denominator, okay? Of course, you see that you can simplify things a little bit in the numerator, so don't hesitate to do that. So this becomes x to the 4 minus 2x squared minus plus x squared, and then I have minus 2, and then divided by this, okay? So up to here is important. But what is, just talk to me about the next step. I will do it for you. What is the next step?
You separate.
Yes. This you need to have. You see, it's not hard. Good point about mathematics is that if you learn the rules, you really need to apply them over and over again. Of course, it doesn't mean probably mathematics the most creative science, but there are very definite rules for that. So I will do it, and if you are not very quick, don't mind. So you just write them patiently and do them step by step. So, and the next one is x squared, x to the 2 over 3. So you see, this simple rule was also beneficial when I was talking about in derivatives, and this is also beneficial. So you see that by just learning and remembering, okay? Learning and remembering. Because you really learn very good at the spot, but the problem is that you forget. You need to start valuing things in your head. Okay, this is the only weakness, I think. This is the main weakness in here, in Swedish system. So you need to learn what is, you need to remember, okay? If you remember, then most of the problems are gone. Okay, and then let us do this in our head. This shouldn't be hard for you at this level. Of course, you can learn how to switch your calculator to the, because this 2/3 is not a number that you can replace it with decimals. It will include infinitely many decimal points, and I want an exact answer. Everyone in this topic, they are looking for exact answers. So either you need to learn how to use the calculator in the fraction mode for complicated calculations, but I recommend you to be able to do these simple calculations in your head. If not, you should go to scratch paper and be able to calculate this. I have this divided by that, so I need to subtract the exponents. So 4 minus 2/3, it shouldn't be hard to calculate it in your head, because this is 12 over 3, so it becomes 10 over 3. So this is just 10 over 3. And the same story here, let me just do it in my head. 2 minus 2/3, it becomes 6 minus 2/3, so it becomes 4 over 3. And then here, there is no x here, but I have to bring it up. So this becomes minus 2 to the power of minus 2/3. So everything now is in order. You see, this function, mainly this type of function you will face in mathematics, but you see that when you simplify that, it would be like this. I myself prefer, when I want to write a function, write it in that form instead of writing it in this form, because there are many exponents, negative exponents, fractional powers, and everything. So I myself prefer to write it in that way, but for my purpose to finding primitive function, that is not useful, even though from my eyes it's more beautiful, but I have to work with this one. Okay, so what should I do? I hope that you can do it in your head. It shouldn't be hard, okay? You need to train yourself with these things. So you know that you need to add 1 unit to this. It shouldn't be hard. You can do it in your head. If I add 1 unit to this, definitely everyone agrees that this is 13 over 3. And then you know that the same number appears here, but it's reciprocal. And this is also very easy. You just do the reciprocal here, yes? It's 3 over 13, as simple as that, instead of wasting a lot of time. Not wasting, spending a lot of time to calculate these things. So this is the first one. The second one, minus. The same story. I need to add 1 unit to 4 over 3. It becomes 7 over 3. And then you know that the number sitting here is 1 over this number. So it is reciprocal, 3 over 7. And here, x to the power of minus 2/3 plus 1. So it becomes what? It becomes 1/3. And then you know that the reciprocal should appear here. What is the reciprocal of 1/3 is 3 over 1. But 3 over 1 is just 3, but there is a 2 also here. So it becomes minus 6. You see, you can do a lot of calculations in your head. N plus C. And that is the final answer that will bring you the full mark. But of course, if you want to do, let us just do some practice to write this in the third form, which is not mandatory for this problem. Okay, so let me just work on the first one. X to the power of 13, 3. So you can write it as the third root of x to the power of 13. But x to the power of 13 can be written as x to the power of 3 to the power of, yes, to the power of 4. Why? Because 3 times 4 is 12, but this is 13, so I need 1 more x. This, of course, this is correct, but useless. Why? Because 3 times 4 is 12 plus 1 is 13, so that's correct. But this power, this exponent is 4, but the root is the third root. So I need to interchange the role of 3 and 4. Yes? So I put 3 here now, 4 here. It is the same because 4 times 3 is also 12. It is x13, but the good point is that this 3 and that 3 are the same. So x4 can be flipped out from the third sign, and the third root of x is left. Okay, so let me write this with blue. You don't need to do this, but I want you to learn that, especially for those of you interested in mathematics. So this becomes x to the 4, a square root of x. And let us do the other one. The other one is exactly the same story. So x to the 3, x to the 7 over 3 is the third root of x to the 7, but x to the 7 can be written as x to the 2 to the 3, 1 more x. Yes? So now these two are the same, so x squared can be flipped out, and the third root of x is left. So this becomes minus 3 over 7 x squared, third root of x, and the next one is just simply the third root of x, no changes needed. So this is now, and now I hope that every time, because I myself don't like that much guesswork, but we started guessing these functions and then proving these formulas are correct, but I don't think there is a way you can come up with this answer as just by guessing for this function. So it means that if I differentiate this function, it becomes that function. And it was not easy at all to guess this formula. Okay, any questions? Any questions? No. So let us continue. I want to write one more problem here. So let us see how do you react. And not on the test, we always have to simplify like you did. No, I want you to learn it. For example, I know, Martin, that you are interested in mathematics. I really want you to learn simplification, but every one of you stopping here, it's completely okay for me to get the full the full points. Yeah, but it doesn't mean don't learn it. Yes, I want you to learn it. I don't want to force you to do this, because the book doesn't force you to do this. Otherwise, if I was free to do that, I definitely will force you. Okay. Anyway, let us go to another example. It's not hard, but I want to see how do you solve the problem. Okay. Yes. Let me write one. I will write some questions and a little bit wait for you, okay? So number 6, am I right? Yes, this is number 6. Okay, so let me write some more for you here. F of x is equal to a plus bx squared to power 2. So you can start doing them. You don't need to wait for me. Sorry, I forgot to put 3 here. You see, the answer was 3 here. So when I want to put it, I forgot to write 3 here. So I'm correcting it. Okay, hopefully the first and the second one at least are finished. Before I start solving these problems, I just want to say something here. You see, you can write it a little more beautiful. If you factor this third root of x out, because all of them have the same thing, yes, in common. So, for example, this is good for your future, of course. If I want to write this, you see the third root of x, the third root of x, the third root of x appears here. So I can simply write it as 3 over 13 x to the 4. And then I have minus 3 over 7 x to the 2. And then I will have minus 6. And then I can take the third root of x in one place and write it in this form. Might be this is a little bit less confusing, because instead of repeating the third root of x 3 times, I just write it 1 time. This is something that I wanted to bring it up. Another way is I wanted to teach you another way to do this simplification. If you are good working with fractions, it shouldn't be hard for you to see that you can factor x to the 1/3 out from here. Yes? So what I write is that f of x is equal to, I factor x to the power of 1 over 3 out. 3 over 13 is left from here. Okay, but you see, when I am factoring things out, I need to divide. I have to divide this in my head by that, so it means that this exponent will be subtracted from this exponent. But this is super simple, yes? 13 over 3 minus 1 over 3 is nothing except 12 over 3. But 12 over 3 has a better name, and that is 4. And the next one, for example, minus 3 over 7. And then what you write here, I am pulling x to the power of 1 over 3 out. So this should be divided by that. So it should be that the exponent would be 7 over 3 minus 1 over 3, which is 6 over 3. But 6 over 3 is simply 2. And then there is nothing left from the last one except minus 6. And then plus c. And then at the end, you can clean this and write it the third root. So you see, you don't need to go through these steps. So I just want you to see these alternatives. So if you want to be really successful in mathematics, don't think that, okay, I solved this problem with one way, why should I solve it in a different way? This will teach you a lot of things if you are interested. So try to look at the problem from different perspectives. Okay, so now I want to start solving them. If you are completely confident about your solutions, you don't need to listen to me. You can continue and finalize all these problems. If you're a little bit shaky, please listen, or at least check your final answer against mine. And if you think that your answer doesn't fit exactly, doesn't match with mine, just ask questions. Okay, so let us now start solving that. I don't know if you are willing to talk to me. So what is the first step here? So the first step is probably, I know, because this is hard to switch on the microphone, talk, and go back. So let us not disturb you. So here I have to expand, but I have a squaring pattern. So I use this quadratic pattern or quadratic rule to expand that. So the first 1 to the 2 is x squared. 2 times the first one times the second one is 2 times a times b, x squared, and then x to the 4. Okay, now I want you to go through the trouble because I want to make sure that at least some of you understand what's going on, hopefully all of you. So what is a primitive function for a squared? I want you to answer it to me. Even if it is wrong, it is valuable for me, because then I know what's the problem. What is a primitive function for a squared?
For a or all?
No, only for the, because I have three terms, I need to consider a primitive function for this, for this, for that, and then add them. So I'm just asking you about this. What is a primitive function for a squared?
A squared times x.
That is my answer. I hope that you are not being tempted to write a to the 3 divided by 3. If you are thinking in that way, please be careful. This is not correct. So you need to mute yourself. Thank you. A to the 3 over 3. This is wrong. Because I told you, when I write f of x, implicitly I am telling you that x is your variable. Any other letter involved in the problem are just parameters. Parameters means constant. Okay? Constants. So it means that if a is a parameter, a is a constant, definitely a squared is also a constant. You are not allowed to use this formula for a squared. A squared is playing the role of this k here. That's it. So this means that you have to write a squared to the a squared as a constant multiplied by x. I am using the first row in that table. Thank you very much. And then here, 2 is a constant, a is a constant, b is a constant. So this combination as a whole is a constant, can play the role of a constant k. So according to the last rule, I can give the role of this 2ab to this c. 2ab should be written. And then x to the 2 is x to the 3 divided by 3. But let me put 3 here because all of them are my coefficient. And then what I have is x to the 5 divided by 5 plus a constant. So this is your final answer. Hopefully every one of you were able to get this answer right. Okay, so number 7. Number 7, I don't think that's a hard problem for you. You have enough experience now. So you know that you need to expand. You know that there is another parameter involved in the problem. That is, you should treat this as a constant. So don't worry. This is just a fancy thing to make things complicated or more symmetric, more beautiful. But a to the power of 2 over 3 is just a constant. And I want to square it. So okay, let us patiently do that. So f of x is equal to, the first one to the 2 is a to the power of 2 over 3 to the power of 2. I have to multiply the exponents, so it becomes 4 over 3. 2 times the first one times the second one, but of course the negative version. It's a 2 times a to 2/3, x 2/3, and then finally plus x to the power of 4 over 3. So expansion is finished now. And now I have to start finding a primitive function. So a primitive function is f of x is equal to. Again, hopefully you are not confused with this. This is just a constant. So I just repeat my constant, whatever it is, how complicated it is written, who cares? I just copy and paste and then put an x in front. But here, minus 2a to the 2/3 is just a constant again, but it is a multiplicative constant. So what I have to do, I have to copy and paste the multiplicative constant, and I need to use the second row in the table to calculate this. Let us do it in our head again. So you write x, you need add 1 unit to it. 1 means 3 over 3. If I add it, it is 5 over 3. And I told you that you don't need to calculate this. It's just the reciprocal of this number. It's 3 over 5, okay? So let me just write it in 2 steps, but of course, it is not hard to do everything in your head. And then here, again, the same story. I add 1 to it. What is 1? If I add it, it becomes 7 over 3. And I just told you it is 1 over 7 over 3 which becomes 3 over 7, and then you have a constant. So if you want to write it in this form, it is a to the power of 4 over 3x, and then 3 times 2 is minus 6 over 5, a to the power of 2/3, x to the power of 5 over 3, and then I will have 3 over 7, x to the power of 7 over 3 plus c. Probably here you don't need to bother yourself to simplify these things in the third form, because the person who gave this to us didn't bother himself or herself to write it in the correct way. So we can just leave it like that. But because we ourselves want to learn mathematics, it's better to do it, okay? Even though the guy was, of course, this guy was not messy. I don't know, do you see a little bit of harmony here, yes? So it is beautiful, writing it in that way. I agree with that person as well. But let me just try to explain a little bit here. So can you do these things in your head? Hopefully. So if I want to write it in the third, so this, I just write the answer, you should convince yourself that. So this would be 1/3 root of a instead of this. And then I have x, then I have minus 6 over 5. And then here, of course, I have the product, so it would be better to combine them both, okay? So I will write it, and that is up to you to convince yourself. So I would write x here, and I will put 1/3 root here, and then I will put a squared here, x squared here. Okay, so that is up to you. If you like it, you can convince yourself that my answer is correct. Let me double check not to confuse you. Yes, that's correct. And then I will have 3 over 7, and then this can be written as x to the 2, the 3rd root of x, and then plus. This is not mandatory, of course, at all, but this is something that you need to know. Okay, so please convince yourself, if you like to later, that this is the correct answer to this. Okay, how many of you were able to solve number 8 and number 9? Any questions so far, by the way? Okay, so what is number 8? Martin, did you say that you solved number 8?
Yes, it is a little bit difficult switching words.
To saying words, yes. Yes, let me see if I have the final answer here. Yes, it is a little bit hard to put it in words, I agree. But can you tell me what is your strategy to tackle the problem? What is your strategy?
My first step is I write it in another way.
Yes.
1 divided by x to the power of 1 divided by n.
And then?
Then I write equals to x to the power of minus 1 over n.
Yes, thank you. Thank you. Good. So then you see that the problem is very simple, actually. The reason that I brought this up, not because this is problem, because I want to train you to work with parameters, okay? So you need to work with parameters. If I just give you 1 over square root of x, this is probably one of the simplest examples that I should have mentioned in the first session. But the only problem here, I want you to get used to working with more than one variable. These are not variables, more than one letters in the problem, one variable and some parameters simultaneously. Okay, so then I would start writing this. Okay, I have to be careful here. So what I should do, I should write this one. And this is also mentioned that n is natural and greater than 1. Because you know that there is only one case that this formula is not valid for. And the case is that the exponent is -1. So I need to somehow guarantee that, don't worry about that special case, this is not equal to 1. this is why I have excluded n equal to 1 from this. Because if n is equal to 1, then what will happen here? It becomes -1, x to the power -1. It is not hard, but you need to wait until the next year to learn that's the ln of x. But we haven't studied that. So this is why I have excluded n equal to 1 for you at this level. Okay, so then it becomes -1 over n plus 1, and then divided by 1 minus 1 over n plus 1. So let me be patient to write this down, okay? Of course, this is the answer. That is not wrong. The only problem with the answer is this is a little bit ugly, yes? So let us try to enjoy a little bit, okay? So what we can do, my suggestion for you is to calculate this one, but by multiplying the numerator and the denominator by n. So the numerator becomes n. The denominator, if I multiply this by n, it becomes -1. If I multiply this by n, it becomes +1. And I don't know, for my eyes, n minus 1 is positive. So I always start with the positive sign because I'm optimistic. Okay, might be. And then I know that what happens for this is exactly the reciprocal of this number. Of course, if you don't believe, you can simplify it again. But let me also teach you, if you want to simplify this, regardless of this, what you need to do, 1 minus over n plus 1. Instead of n, you write n over n because you want to have the same denominator. So then it becomes n, and then you see it becomes n minus 1 plus n. For the same reason, I write it as n. So it was predictable for you. I told you that. These two numbers are always reciprocal, okay? So then it becomes x to the power of n over, n minus 1 over n. So that is the answer. And if you want to write it as the third sign, that's the end of the story there. But if you want to write it as the third sign, it's not that beautiful, I think. So you can write it in this form. But that's also good to know. So this is the answer. So it was not hard to read it, by the way. You see, it is hard to read it here, but I would say n over n minus 1 times the nth root of x to the n minus 1 plus a constant. Okay. Any questions? Let me, yes?
Will the point be reduced if you write without c in the test?
Yes, because I have mentioned all primitive functions. If you go back to look at your notes, when I started this exercise, I mentioned that all primitive functions. When I say all primitive functions, I really want you to write this C for me, because this is the way that you communicate with me. You understand what is the meaning of the article all compared to the article a. Yes? This is important in integral calculus, because this shows you that you understand that there is no unique. If I give you a function and I ask you to differentiate it, the derivative is always unique. You will get one single answer in differentiation. But in the process of primitive functions, this C indicates that the answer is not a unique answer. There are infinitely many answers, but the good thing is that all of them just differ by a constant. Okay, now there is a little bit of time, so let me finalize this problem. I cannot finalize it. I will leave it for you. We solved this one. Let me just repeat again. It's mandatory to be in the lesson on Friday physically in a school, okay? We start as usual from 8:30 to 10 minutes to 10. And of course, this is the recap session for the exam that is coming, okay? I will not teach anything new. I will just recap what you need to know. I will highlight the main points if you have forgotten. Okay, so let me just solve this problem for you, and then okay, so can you have do you have any suggestions for how to calculate this one?
We can first go back to the exponent, adding +1.
Not immediately. Not immediately. If it was just x, you are right. There is a constant here. What should I do with this constant? This is the multiplicative constant for x, but not the multiplicative constant for the whole combination. I intentionally put this there. Okay, be careful. That was the reason. You cannot immediately start. This is again not possible. So
Distribute the exponents.
yes, so that is the idea. If I have a product a times b to some power n, I can write the first one to the n multiplied by the second one to the n. So what I would do, I will do the same thing here first. Then you might say that, okay, God, what can I do with this? But don't worry, this is just a constant again. It's written in a fancy, complicated way, but who cares? That's a constant. And then I have x to the power of 1 minus n over n. So now I can start. I can say a primitive function for this. This can be considered as a constant. How complicated it is, we don't care. N is a constant. Why? Because x is my variable. So any other letter involved in the problem is called a parameter. It's a constant. So this fancy constant, I just write it down. And then, as you, Martin, said, I will do this one in the way that you told me. So what I do, I will write x to the power 1 more. And then divided by the same expression. And then a constant at the end. Of course, this is the end, but you know that this is not very beautiful. So let us try to make it more beautiful. So then it becomes n, 1 minus n over n. I just copied and pasted this one. But then I hope that you have enough experience now. To get rid of this, I rescale this fraction by n. I multiply the numerator by n, the denominator by n. Okay, what happens? You can just do it in your head, yes? If I multiply this by n, it becomes 1 minus n. I multiply this by n, it becomes positive n, and this is cancelled. It is just simply 1. And who cares to write 1 in the denominator? No one. So let us just keep it as n. Okay, now my question for you. Can you answer this question immediately? What would be the power here without calculation? What would be? What would be the exponent here?
1 over n.
Exactly, thank you. It's 1 over n because I told you that what appears here and what appears here are reciprocal. When I calculated this as to be n, why should I spend more time to calculate this again? I just reciprocal it. It's n, it becomes 1 over n. But now you see that I can make it even more beautiful. How? How? Because even though these are constants, but let us work with them. This is the exponent. The exponent of this n is 1. So because the bases are the same, so I write the same base and I add the exponents, yes? And then instead of this one, you know my taste, I prefer to write it with third sign and then this one. But still, I can simplify this more, yes? Can I? Let us go in the scratch paper. In the scratch paper, I have 1 minus n over n plus 1. What can I write? Instead of 1, I can write n over n, and then I add them. N plus minus n is gone is 1 over n. So that is nothing except 1 over n. No? This is beautiful, isn't it? So it becomes n, and this is 1 over n, and this is the nth root of x, and this is c. But this one is also the nth root of n, and this is the nth root of x. But why should I write two things? I just write 1 nth root and multiply these two. Okay, so you see, I love simplification. You should love it. Okay, now you realize, do you understand this one better or this one? Of course, that is up to you if you want to leave it like that. But even I hope that you agree with me, every one of us gain more by looking at this beautiful expression than this ugly one, yes? So Simplification is an art in mathematics. You need to value it first. You need to enjoy it. If you don't enjoy it, of course, you don't bother to learn it. But if you enjoy beauty and things like that, I will never, ever leave this expression like that, even if I don't get points for it. Because what I care is mathematics, not points. Okay, so that is the final answer. Thank you very much. By the way, let me ask you, I always hesitate to say this, but if you think the videos are useful, please give me a thumb up, okay? I can be your guest for a thumb up, because then these robots of YouTube will, I don't know, will show these videos, offer these videos to other people. But if you don't like them, of course, yeah, please do it whenever you watch a video. If you don't like it, please dislike it, because then I will understand, might be I am doing something wrong. And if you like it, please just show this feeling. Okay, thank you. Okay, any questions? So don't forget, I will write on the school soft, be physically in a school on Friday at 8:30 for the recap session for the test. Thank you very much. I will end this stream and I will be on Zoom.